All right, so we are looking at 2.5, number 39, which says I have a 4 by 4 matrix with ones on the diagonal. So 1, 2, 3, 4. Negative A, negative B, negative C above the diagonal. Negative A, negative B, negative C. And presumably zeros elsewhere? Let's go with presumably zeros elsewhere. Oops. So I'm going to go with presumably zeros elsewhere because they said it's a bidiagonal matrix. And to my mind, that means it has two diagonally things. And I'm seeing one of those as being the actual diagonal, and the other one as being this thing. Okay, so this is my matrix A. I'm supposed to find an inverse for this. So to avoid rewriting this a bajillion times, I'm going to take this thing and augment by... What do I need to augment by?
4 by 4 identity matrix.
Okay, so 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. Great. Okay, now what?
I eliminated E, or yeah, 1, 2. Elimination matrix on 1, 2, and then I went.
Wait, you did 1, 2?
Yeah, so I multiplied row 2 by A, and then added it to row 1.
Oh, okay.
I think that's what I did.
Yeah, so you pushed your kind of problems into this area? Okay. So, I'm going to... Sure, what the hell. I'll follow on. I probably would have started this from the bottom and gone up.
Okay.
But you do you. So let's do it your way. So we're going to do the new row 1 is the old row 1 plus A times row 2. Okay. So that's going to get me to... let's see, I'm going to leave everything all the other rows the same.
I actually did it all. I eliminated A, B, and negative A, negative B, and negative C all in one kind of go. Or maybe that's where
yeah, my guess is just that that's a lot of stuff.
Yeah.
Let me try what I was suggesting, just because it'll be less writing on the board. Oh, I guess I need that thing. We'll leave that even though we can't erase it. No big deal. Okay, so I'm going to do the new row 3 is the old row 3 plus C times row 4. So with me on that? So that's going to leave my top guys alone. This is actually one of the problems where teaching online would be better, because I could copy and paste this, and then just alter pieces of it. So my bottom row is going to stay exactly the same. In fact, my bottom row is going to continue to stay exactly the same, right? Because that one's already done. So C times row 4 is going to give me a 0, 0, 1, 0. Let's move me on that. And then on the other side, what happens?
Shouldn't it be 0, 0, 1, C?
Okay, 0, 0, 1, and C. Okay, now my next scheme is going to be to take row 3 and hit row 2 with it. This is really me back substituting, by the way. You guys see that? So, I'm going to do row 2. The new row 2 is going to be the old row 2 plus B times row 3. So just to make that explicit, because now I've got slightly more numbers. B times row 3 is going to be 0, 0, B, 0. And then on the other side, I'm going to have 0, 0, B, B, C. You guys with me? So I'm going to add those together. And I'm going to end up with 1 minus A, 0, 0, augmented by 1, 0, 0, 0. And my bottom two rows are going to stay the same. So I'm just going to squiggle those. Those ones are done, right? Okay, and then my second row here is going to become 0, 1, 0, 0. With me on that? Adding black to purple there. And then on the other side, I've got 0, 1, B, B, C. Yeah? Okay. Alright. Now what?
Now we multiply A by row 2.
Yeah, I'm going to multiply row 2 by A and add it to the one above.
Okay, I see, yeah.
And I think what that's going to get me, if I'm following this pattern along correctly, right, is I'm going to end up with the identity over here. And my second row, at least, is 0, 1, B, B, C. My third row was 0, 0, 1, C. My bottom row was 0, 0, 0, 1. And my top row, what's my top row going to end up as? Can we see the pattern?
1A, B, A, B, C.
Perfect. Is that what the book had?
Yeah. Yeah. I think where I went wrong is I started with the first row.
Yeah, so you should be able to do this starting with the first row. It's just going to continue to push problems to the right. So like when you do that elimination with the first row,
Yeah.
you'll have minus AB that'll end up here and a 0 there.
Okay. Yeah.
And then you'll have to multiply the third row by something a little weird. It'll all work out, but it'll be just a little bit weird.
Okay.
You guys see that? On a lot of these problems, you're going to have some choices to make, and if you make some of the choices, it's not even that they're wrong or bad necessarily. It's just like sometimes if you start down a path, it can be a little bit worse than if you had started down a different path. That's that like if you consider the column multiplication picture, sometimes the like thing you're trying to see is easier than if you use the row multiplication picture. Here, when I see a matrix like this, I'm thinking back substitute because like I'm a well-trained algebra student. So some of this you can just fall back on your like honestly algebra training will be the best place to get some of this stuff. Cool? Questions?